So let's start off with this question. Here we have number 8 from section 2, May 2018. The diagram on page 25 shows 6 points of the function, right? So remember, your function is, it comes or it looks in different forms. So we could have y is equal to something, f of x is equal to something. So in this case, our function is this. Y is equal to 3x plus 1, right? And this is the formula of the equation of a straight line. Remember, y is equal to mx plus c, right? So if we were to watch a question like this, 1 over x, whatever x is our y-intercept, and 3, so this will be equal to our c value, and 3 will be equal to our m value, right? Because it's already uniform. So yeah, this is our function. We don't need this, but it's just for you to be able to identify with each question, right? And they said they gave us x values and y values. What is the name for our x values? What can we call it?
Domain or input.
Correct. Our domain. Our x values are our domains because we take these x values, and how do we get these y values?
Okay, it's into the function.
Substituting it into the function wherever we see x. So this is our codomain or our range. So when I substitute 0.1 into this, I will get 10.3. When I substitute 0.2 into this, I'll get 5.6. So part 1, complete the table by calculating and inserting the missing values. So you should be able to find the answer for this and find the answer for this for me, please. So this will give us 3.5, and what's the answer for the other one?
6.5.
6.5. Keep it as a decimal. 6.5. Nice. So that's our 2 marks. On the diagram on page 25, the ordered pairs shown in the table have been plotted except for the missing ones using your answers in A1 plot the missing points. So you're going to plot the XY values, because remember it's X, Y that you're plotting. You look for your X first, then you look for your Y. So we're going to plot 0.5, 3.5, and then 2, 6.5. Everybody with me?
Yeah.
So we're going to, so first of all, we need to watch out the boxes. They said 1, 2, 3, 4, 5. So this is a 5-to-1 scale on the x-axis, and on the y-axis we have a 2-to-1 scale. 2 boxes representing 1. Everybody with me, right? So where would be 0.5 between 0 and 1? Where would 0.5 be? We have to count it, right? Count and see where you could put your 0.5.
Somewhere before the second block.
Before the second block? Yeah?
After, sorry.
So each block is how much?
0.2.
Correct. Because if we count 0.2, 0.2, 0.2, we get it. So 0.2, 0.4, 0.8, 0.6,
6.
0.8 and then 1. Everybody got that, right? So if we count 0.2 between each, we'll separate the 5 blocks to get you to sum up to 1. So therefore, 0.2, 0.4, 0.6 is going to be in the middle of 0.4 and 0.6. So this is our 0.5 here, right? And then we're going up to 3.5. Where would 3.5 be? So we know it's between 3 and 4. So it's going to be exactly in the middle, right? Because we'll have 0, 0.51, 1.52, 2.53, 3.54. So it's going to be around here. Everybody got that? Everybody understands that? Yeah?
Yeah.
Awesome. So where's the next one? It was 2 and 6.5.
Yeah.
So where's 2? Here, right? And 6.5 is here.
Yeah.
Awesome.
This would be a line of best fit because not all the points like that.
What's that?
Especially, this would be a line of best fit.
No, it would not be.
It'll be a curve.
It would be a curve because it's a what they told us.
Yeah, so it's smooth curve.
Except the missing ones using your answer with a smooth curve, right? So pay attention to what the question asking you to do. So now we go and we connect our points with a smooth curve. So this is the first point. So no rulers, we're doing it freehand. Of course, it's not going to look as horrible as my own. Right, go from point to point. It's a curve, so you're gonna bend right here and go up. And what's the name of this curve here? What's the name of this function that we just drew?
Y equal 3x plus 1 over x.
And that's the name of our curve here. That's our function. Yes?
Yeah.
Now, they told us by drawing an appropriate straight line on the diagram, find the approximate solutions to the equation 3x plus 1 over x is equal to 6. So they are telling us draw a straight line on the graph that represents this. Let me see who's been revising. What does this mean? What is familiar in this here? 3x plus 1 over x is equal to 6. What can you identify from this?
The mx plus. No.
The whole function is equal would give you 6.
Correct, the function 3x plus 1x, they just put it in front. So this could have been 3x plus 1 over x equals to y, right? Yeah, but they said it's now equal to 6. So 3x plus 1 over x is equal to 6. What does this tell us?
Y is 6.
Y is equal to 6. I think I remember us going through questions like this talking about it last time. This tells us that y is equal to 6. So we are to pay attention that they are telling us that your function, the y value for your function is equal to 6 now. So you are going to put that equal to 6. And if we know that our assumption is y is equal to 6, what can we do with this?
Plot it.
Draw a line.
Draw a line. Remember, you don't really plot a y is equal to 6 because you already know what the line is.
You know what I mean? Draw a line.
All right, yeah. So y is equal to 6 is a vertical going this way or this way.
Horizontal.
Horizontal or vertical line? Horizontal, correct?
Yep.
Or always remember it's opposite the axis. So if we know the y-axis is standing, so our y line will be across. Yes? So we go at the point. What point do we go to?
6.
6, and we draw a line going across with a ruler. All the way across.
And we have to read out the points where it cut the function.
Where it cut the graph, correct, is
Graph,
right.
yeah.
So it cut the graph here and here. How do we find our values for that? What do we have to do? We could draw a line going down to see where it will fall, right? So it looks like it's on the second block. I'll say it looks like it's on the first block. So the first block from here. So what point is this here?
1.8.
So that's 1.8, nice.
1.82 or 1.81 at the back.
Oh, correct. It's like average. I will actually leave it as 1.8. Well, we could do 1.82, we could do 1.85, 1.2, 1.4, 1.6, 1.8. I wouldn't even say 1.8.
Probably 8.4.
So on average, each block,
Or
you can
3.
leave it about 1.82, right? Even if you put 1.8, it would still be fine, right? Because that would be the closest rounding to this line here, right? So
I thought they used to mark accuracy.
what's that?
I thought they used to they're marking accuracy once the graph is involved. You
So
know?
what did they say?
Okay. Okay.
Yeah. Right. So once you approximate, you could actually approximate this to 1.8. Yes? Everybody got that? So
Yeah.
1.8, because that's the closest and we could approximate it. All right, and this one could be how much? This one, I would say the first line before as well. So about how much? Before 0.2, we could say 0.2 if we approximate it as well. Yeah? Everybody got that? Any
Yeah.
questions? Right, and therefore, what they said to do, find the appropriate solutions. Right, so your solutions, of course, those were x values, so x is equal to 0.2, and x is approximately equal to 1.8, and x is approximately equal to 0.2. So we are viewing a question like this and we're briefly going through it, right? we have two functions. Remember when we did functions, I like to write it in a form that I'm familiar with. F of x is equal to 5 minus x. G of x is equal to x squared minus 2x minus 1. Now they are saying that the 2 points are going to meet. The 2 points are going to meet, and we know that when two things are going to meet, we know that this is a curve. Right? One is a curve because this is a quadratic and this is a straight line. So the curve and the straight line are going to meet at 2 points, for example, right? So now they want us to find the two coordinates. Find the coordinates of M and N, the meeting points. So remember when we did this? Well, from our previous question, we had 3x plus 1 over x is equal to 6. Yes? This was our curve and this was our straight line. It was y is equal to 3x plus 1 over x and y is equal to 6. We drew this curve, we drew this line, and we got the 2. So what do we have to do on this side here? So we have this is equal to this. What is this telling us to do across here? X squared minus 2x minus 1 equals to what? What would it be equal to? Right, so we put the quadratic equal to the linear, so x squared minus 2x minus 1 is equal to 5 minus x. So we are going to solve for these two values. So what are we going to do now? How do we go about solving this? So when a question tells us that two lines meet, we are going to find points of intersection. And for us to find the points of intersection, we just put the two functions equal to each other. So I can say 5 minus x is equal to x squared minus 2x minus 1. First thing we do is let them be equal to each other. The second thing we do is we turn it into a quadratic equation. So we put everything on one side and allow the equation to be equal to 0. So I am not going to bring my x squared across on this side because I will change my coefficient of the x squared to negative, and I don't want it to be negative. So I am going to send across the 5 and the minus x. So I'm going to have x squared minus 2x minus 1 minus 5 and x is equal to 0. Yes, even though it looked like it came across on the right, even though it looked like it went across on the left, it actually went across on the right. Look at the difference in these signs, right? Minus 5 plus x. I just put the equal to 0 on the right hand side instead. The third thing we're going to do is we're going to simplify this by adding up our like terms. So we just have a x squared minus 2x plus x is minus x, minus 1 minus 5 is minus 6 equals to 0. The fourth thing we're going to do is solve our quadratic. We know a is equal to 1, b is equal to negative 1, c is equal to negative 6. We multiply a by c, which is negative 6. We find two numbers that when we multiply them, we get negative 6. When we add them, we get negative 1. That will be negative 3 and 2. So we write it as x squared minus 3x add 2x minus 6 is equal to 0. Then we factorize. So x open brackets x minus 3 plus 2 open brackets x minus 3 equals to 0, ensuring that our brackets are matching. X minus 3 by x plus 2 equals to 0. So we are done with this part here. Now we're going to actually find the values of x. So we know that our function at this point is equal to 0. That's our y value. So we already know our y value is 0. It's just for us to find our x values. So when our y value is equal to 0, x plus 2 is equal to 0, our function is equal to 0, x is now equal to -2. And then x minus 3 is equal to 0, x is equal to 3. So we can say m, the coordinate m, could be -2, 0, and the coordinate n could be 3, 0. Yeah, that's our question.
Why it's
So it's equal to 0 because remember, it comes like I did this. 5 minus x is equal to 0. When 5 minus x was equal to y. Yeah. So I put my function equal to 0. And remember, anytime my function is equal to something, that is the y value. So remember when we had 3x plus 1 over x is equal to 6. 6 was the y value.
oh,
Yes.
because we always work out for the y.
Because we always solve for the y. We substitute our x into our function to get our y. So whatever the function is equal to, that's our y value. So what type of function is this? 1-to-1, many-to-1, one-to-many, many-to-many,
Many-to-1.
many-to-1, because we had two different x values going to one y value, many-to-1. Therefore, it is a function and not just a relation. Yes? So our y value was 0 because when we simplify the quadratic, it was equal to 0. Therefore, this was our y value. So we're moving up 8a. The straight line. So they are telling us that this function here is a straight line. X is equal to 5 minus 3y is a straight line. This straight line is going to intersect the x-axis. The x-axis is here, right? And the y-axis is here. So it's all about reading and understanding. The straight line is intersecting the x-axis, which is here, at P, and it's intersecting the y-axis at Q. So P could be either here or here, and Q could be either here or here. Well, somewhere. Everybody understand what's happening, right? The line has to cut P and Q, or P and Q, or however. It has to cut the y-axis and the x-axis. Everybody understand what's happening, right?
Yes.
Right. So they said the line is going to intersect the x-axis at a point P. So it must cut somewhere on this line, and it must cut somewhere on this line. What is the name for when a line is cutting the x-axis, the point here? What would P be called?
The x-intercept.
Correct. So when a line cuts the x-axis, that point P is called the x-intercept. And what about if it's cutting at a point on the y-axis, Q? What Q would be called? The y-intercept, yes? So basically, they are just asking us to find the x-intercept and the y-intercept. What's the first thing we're going to do with this? To find out any information, what's the first thing we have to do?
Put values into the function.
Huh?
Is it put values into the function?
How do I find the gradient and the y-intercept from this function without doing anything? Without plotting? There's a format you could put your line in that you could easily identify what is the gradient and what is the y-intercept. What
The
format
gradient is 5, no, sir?
Huh?
Y equal mx plus c.
So you have to put your line is equal, yeah, you have to put your line in the form y is equal to mx plus c. Is it in that form right now?
No.
How do you?
Because the true y is all on the right side and the x is on the left.
All right, so go ahead and put it in that form for me, please. Y is equal to mx plus c. So that basically means we're going to make y the subject of the formula, right? What's the first thing we're going to move? We're solving for y. We're making y the subject of the formula. What's the first thing we're going to move?